Thanks everyone so much for joining today. This is a really, really exciting one. We're joined by Peter Broadhurst, the head of engineering at Kaleido. He has a very, very extensive background in enterprise middleware, networking, cloud architecture, and over the last handful of years has definitely become a bona fide subject matter expert in all things enterprise blockchain as well. So super stoked to have him here, and he gives great demos. A few quick pieces of admin before we get started. Just want to draw everyone's attention to the fact that every one of these talks on Tech Tuesdays and Walkthrough Wednesdays has been recorded. You can find these on our YouTube page. Just go ahead and search for Kaleido Blockchain, and you can dig through the list, fully curated, and you can go ahead and grab the topics that you're interested in. Today, we're focused on PrivateStack deployments. So for some additional context beyond the demo and insights that Peter shares with us, there's also a blog that is written by none other than Peter himself. Takes you through a very nice sort of synopsis of what this orchestration gives you and the power that it can provide when combined with other fully managed cloud infrastructure deployments that you get on Kaleido, on AWS, or on Azure. Please feel free to use the Q&A or the chat, or you can raise your hand if you'd actually like to ask a question out loud. And then we will share some contact information towards the latter half of the call. So without further ado, I'm going to stop sharing and turn it over to Peter to give us a demonstration of Kaleido PrivateStack today.
Hi everyone, thanks for joining us today. So hopefully now you can see my screen and we're going to jump straight into it, but I wanted to give you a quick picture of what we're going to see today. So as hopefully you're aware, for a long time now, Kaleido's provided fully managed enterprise blockchain infrastructure, high SLA, not just the chain, but all of those services that are really needed to actually build your project with blockchain at its core in a decentralized way across multiple participants. Now, one of the things that we've been passionate about since the very start of Kaleido is making sure that those participants in the decentralized network have the flexibility and the choice to participate in the network the way that they need to participate. Now, the way enterprise adoption of blockchain has come about, all the real value that's been generated so far is in permissioned blockchain networks, which is obviously where Kaleido has specialized. And running and managing and operating as a group, a permission network comes with lots of challenges. And it turns out that the fastest way, by a huge margin, a margin so large that it's been really the only adopted model for production networks so far, is to go fast by having enough consistency and enough alignment between the way those participants are doing things that they can agree on a technology stack, they can agree on a model for things like hosting and management and how they do HA and DR in a way that everybody trusts everybody else's resilience and security. And while every participant feeling like they have enough control over their data and their keys. Now, for Kaleido, that's meant providing flexibility and choice over things like where you deploy. Is it AWS? Is it Azure? Is it in Europe? Is it in the US? So that sort of flexibility and choice for each of the participants to onboard, but also to provide a fully managed infrastructure that means that a new participant can onboard in seconds. There's no way for an existing participant to sort of block the onboarding and permissioning of a participant that's been agreed by the group or agreed by the governance structure or agreed by the network operator if there is one. And that's meant for most networks relying, whether they're using Kaleido or not. The reality is most networks have actually gone for fully cloud-based infrastructure today. That's the way networks have been running. But a lot of these networks have wanted, some of the large players in those networks have wanted to run infrastructure in their own private on-premise data centers for a long time. It's something that we've been working with real production networks on throughout Kaleido's journey. And what I'm going to be showing you here today with PrivateStack is that in action in our full, generally available PrivateStack service. And what this provides is the ability to have multiple nodes running up in the cloud, fully managed by Kaleido across all of our deployment zones, whether they're Azure or AWS, and also to have a node with all of that same open source running, no difference in the open source stack that's running here in the private environment, but that can be in any network, self-managed, fully under the control of whoever owns this network. And we'll talk a little bit in more detail, sort of after we've gone through the demo, on exactly what that means and how the technology stack works. For now, what I'll just say is that we actually need some extra components that come along with the open source nodes themselves that Kaleido provides to securely bridge that node to the backbone that everybody else is connected to and running and managing those nodes, so that when somebody else onboards, whether they onboard in the cloud or they onboard their own PrivateStack node, it's cross-connected to every other node in the network, whether that's a PrivateStack node or whether it's a cloud-hosted node. So that's what we're going to see. So with no further ado, let me just go and show that to you end to end. So we're going to log in to Kaleido here. It's going to start, I'm sure, like any other Tech Tuesday with Create a Network. I'm sure many of you who have been to a few of these before have seen this. So I'm not going to go into the details here, but we're creating collaboration space for multiple of these entities to come together and collaborate on the blockchain solution. Very uninventive name here. I'm going to give that, if I can type correctly. And we're going to choose, for example, where the metadata is homed for this region and may be important to that business network. We're going to whitelist in lots of other regions where people can run infrastructure. And we now have that collaboration space within which I could be setting up memberships. I could be inviting other participants to join. I could be collaborating with separate administrative teams, all managing their own cloud accounts, coming together and collaborating inside of one space. I'm not going to do any of that. What I'm going to do is go straight to the tech, and we're going to go and create an environment. Now, what an environment is in Kaleido is a blockchain at its core, a single blockchain at its core. It provides an isolated network environment, cross-cloud, cross-region, within which a set of resources can be run. So think of this as your development environment, your pre-prod environment, or your production environment. Or maybe you're experimenting as a group with lots of different consensus algorithms and you want different environments for those. So each one of those will be an environment. You do choose the core technology at this point. And then this next screen is an interesting one. I'm going to choose between our second or third generation networking technology inside of Kaleido. So I guess 18 months ago or so, maybe a little bit more than that, we made generally available our cross-cloud, cross-region networking. That was generation 2 of Kaleido's infrastructure stack. We're now able to provide generation 3, which is a fully hybrid self-service environment for onboarding, not just nodes across multiple clouds and multiple regions, fully managed, but also to join in nodes which are running in your own private network. So I'm going to choose that here. Give it a simple name here, and I'm going to choose my core blockchain technology because it's the one I set up. I'm going to choose Quorum with IBFT. We don't support Raft in cross-region, cross-cloud, or hybrid environments. It's only suitable if you're limiting to a single region there, so that's not an option there. And I'm going to stick with a 5-second block time on my chain, and that's going to be generating me a Genesis configuration for the chain, and it's there ready for me to create some nodes. The first nodes I'm going to create are those ones that we see in the cloud. I'm just going to create 2 of them for the moment. So I'm going to go through, I'm going to create a first node in AWS. Let's click through and create that. And we're going to create a second node here, and this one I'll just choose to be in a different location. Again, this one's going to be fully managed, and I'll pop this one on the west coast of the US here in Azure. And even if you're using fully managed infrastructure on Kaleido, it's really important to us, and has been critical through the journey as we've been working with production networks, for those participants, even with managed infrastructure, to still feel control of the data, feel control of the keys. So even with our managed infrastructure, you're able to provide additional key protection in your own privately managed cloud account. You're even able to use Hsm devices for signing, which are hosted outside of Kaleido in your actually hardware devices enabled through cloud-based trusted key path in AWS or Azure, or if you want something slightly simpler, you can use HashiCorp Vault as a software key management device, and we provide an open source signing extension to turn it into a signer, a little bit like the functionality of a HSM, but of course at that point it's a piece of software, and you can run that in any cloud, and you set up a twice secure trusted key path with mutual TLS and a security key on top of that. Anyway, I diverge, but just to say, even if you're using the managed capabilities, we provide a lot of control over those keys and that data. And actually what we find is that's the level of resilience that you get from having these very high SLA managed HADR for you out-of-the-box nodes in Kaleido is probably going to be the most popular in your business networks. And it's really those customers have particular data integrity requirements, or a few anchor tenants in your network that are going to want to take on quite a large burden of setting up all of that HA and DR management themselves. So go through, create that second node here, and what I've got is I've got a blockchain node, sorry, a blockchain environment here. I've got a system monitor which we manage for you, back to the Block Explorer and an off-chain index of the chain and some of our smart contract management capabilities. We've got a node running in AWS, and we've got a node just starting up here in Azure in a different region, one on the East Coast, one on the West Coast. But I, as of yet, don't have any nodes running outside of Kaleido. They're all fully managed. So we're now going to move across to kind of what's new here, so, something you won't have seen before in a previous demo. The first bit you might have done if you've seen our quarter demonstrations, which is to create a network bridge. And what this is going to do is it's going to give me a runtime dedicated to me in the cloud that I can connect to, and I'm going to have a corresponding endpoint that I'm going to run locally. So I'm going to describe it about where I'm running this. Actually, I'm going to describe it as my laptop, because that's where I'm going to be running it. And I'd like the cloud-hosted part of this bridge, this secure connectivity endpoint, I'd like that cloud-hosted part to be close to me in the East Coast here of the US. So this is standing up now a piece of infrastructure that is one side of this bridge, standing up this side of the secure bridge that Kaleido provides. And once this side is stood up, then what I can do is I can start to go and set up my local environments to be able to run a node with a corresponding agent, and we'll see what that's for later, locally on my laptop, and join it with all of these two nodes that I've created up in the cloud. We haven't created the third one yet. So that bridge is ready up in the cloud, and I'm going to click this sort of magic extra button. And this is where really stuff does start to get new compared to what you might have seen previously. And this is a very simple thing. What I'm doing is I'm turning this bridge connectivity into a deployment zone. It's special compared to the standard out-of-the-box deployment zones in Kaleido because it's just for my membership. Nobody else in the consortium can use this. It's dedicated to me. And this deployment zone is now somewhere that I can go and create a node. I can now choose an extra option in the list. So node 3 PrivateStack is going to be a node running in this deployment zone, the one tied to the secure bridge for my laptop. So I'm going to click next here, going to ignore all of these for this. And of course, I don't have the same options for configuring teacher sizes or resource because I'm going to be responsible for provisioning the infrastructure for this node. And I'm going to be self-managing it myself here. And because of that, Kaleido is not going to be able to get it out of initializing without my help. It's going to be sat in initializing until I do some work because Kaleido can't reach into my laptop and start it for me. What I need to do is I need to do that work myself. I'm in control of that. That's very important, and we'll talk about the layers of control that you have as an administrator of one of these PrivateStack nodes. So what I do need to do is I need to set up the other half of my bridge. So what I'm going to do here is I'm going to create a secure connectivity endpoint credential for the bridge. I'm going to download the configuration of the bridge, and I could Also go and download the bridge software itself. So this is a package that Kaleido provides pre-built for you to run in your private infrastructure, be that in a private cloud VPC, be it in your core on-premise private networks, or, and we'll talk about this a little bit later, be that in a yellow zone between your core private networks and the outside world. On this case, it's all one place. It's just going to all run on my laptop here, and I get this configuration file, which is almost everything that I need to stand up the bridge. And I'm going to make one tiny little tweak to this. So let's have a look inside of it. The file that got generated for me by Kaleido, you can see it's got secure connectivity details to be able to create the bridge to the remote site here, and it's got details of what I can connect to. And then there's this special section down here, which is a very stringent whitelist of a very small number of places that can be connected to in my local network because I'm establishing this bridge with Kaleido. And only the things which are inside of this file can be connected, and they're going to be connected to using a host name. Now, I could put this inside of a Kubernetes environment, or Docker Compose environment, and I could resolve this host name. I'm going to do something even simpler here. What I'm going to do is I'm going to tweak the configuration to say the resolved address of these host names is my local IP address. And this very simple tweak to the configuration is going, if I type it correctly, glad I checked my typos there, is going to say when we want to connect to this endpoint, connect down using just the local host as the resolved address for that. And you'll see that there's actually an API component to this that's going to be established locally, and there's a unique, in addition to the network security, there's a unique key that's been bound between my private endpoint in Kaleido and my local environment, which is going to be used for some very simple API commands, and we'll talk about what those are. So I've now got the configuration that I need. I can actually go and I can start up the environment here. So this very simple command here is just saying, please start up the local network bridge and use that configuration file that was downloaded. And you'll see that it's started up a set of sort of local proxies that exist for every one of the nodes that are available inside of Kaleido. So I don't need to know anything about Kaleido's internal network, and Kaleido's internal network doesn't need to know anything about my internal network. And we'll look at a diagram after we've gone through the demo here and talk about some of the detail on what that really means. So I've set up this environment here. I've still got my cloud infrastructure up there and ready in the cloud. And what I'm going to do is I'm going to go back to this blockchain node up on the cloud side. And you'll see it's still here in initializing state. What I'm going to do is I'm going to click verify connectivity. And what verify connectivity is going to do is it's going to use this, this bridge that I've got now running locally, and it's going to talk to the software that's running on my local laptop. And for that to be true, what I need to do is I need to start the API server, this little agent that Kaleido provides, as well as the network bridge, locally on my laptop, so Kaleido has something to talk to. And this little network bridge, this little agent that's provided, is going to take a couple of bits of configuration here. The provider, the consensus algorithm, whether I'd like to use Tesla, as this has got, I'm going to be running Corda, I'm going to be running Cohen here. And I need to know this one port, which I just need to copy from here. Start this up, and what Kaleido's done at this point is it's actually generated for me a data structure in my local environment, which is just enough for me to start up a node. It's actually generated an Ethereum account for me. I could do all of this key generation myself if I wanted to. I don't need to use the pre-built get started in the second single click deployment here, but that's what I'm going to be doing. Just run that one command. It sets up everything locally for me. and we'll see that I've now got a data structure inside of here, and inside of data, I've got a directory, and it's got some keys inside of here. For example, it's got the node key that's been generated for me, but it doesn't yet have a Genesis configuration, and that's because the Genesis configuration needs to come from the cloud and the rest of the network down to me. So this one simple button, verify connectivity, I click that here, and what we'll see is that Kaleido talks down through that bidirectional network connectivity down to my local node, and let me just check I didn't. Yeah, I did. There we go. And it talks down. The reason why that was failing was because I already had an earlier setup running there, and it was disagreeing over the identity. So now what Kaleido's done is it's talked to my local node, and it's done an exchange to find out the identity that's been generated to my local node. It can't get hold of any of those key materials, but it can ask what the public keys are that have been generated for this node. And you'll see it's entered join state, and it can't get all the way to started because it can't go and start that node up for me. But what now this local stack has done for me is if I look again in that directory, you'll see that it's created a start.sh script. It's actually created two of them. It's created one for Ethereum, and it's created one for Tesla as well. And you'll see inside of here, it's a very straightforward script that just uses the standard command line of the open source to start it, but against generated configuration. So you can edit that configuration, it's in your control, you can change it as you would like, but you don't need to if you just want to get started here. And I can start up Tesla locally. And it's going to use the key materials that have been exchanged using a CSR exchange for TLS between my local laptop and Kaleido that's all been orchestrated. And that's going to start up. And then I can go and I can start up the Ethereum node as well. So that's starting up vanilla Core in this particular case. And that's starting up Core on my local machine. I can go and I can tell the logs here, so we can see it starting up. And you can now see that it's happily connected to the rest of the network, even though it's running on my local laptop. And the Kaleido hosted nodes don't have external connectivity for P2P. I'm now joined to this network, and the Kaleido side sees my node as running and started. More than that, I can pop up another session here, and I can do a get attach to my my local node using the IPC address here, and I can do an admin.peers. And what you'll see is that I know about 3 separate peers, but there is zero networking information leakage happening here. I have no idea how Kaleido runs their network. Kaleido has no idea how I run my network. There's bidirectional proxies here. There's a reverse proxy from Kaleido down to my node, and there's proxies from my node to every node that's running up inside of Kaleido, which means I only know about where my local bridge is running. And in this particular case, that's running on the same computer. So everything looks like it's there on 127.1.1. And let's have a look at just a little bit further, and let's just kick off a little bit of workload against this environment. So I'll kick off a little bit of workload that we can just have running in the background here as we're talking. So I'll pop open the Block Explorer here, and let me kick off some workload using our simple exerciser tool that you can all use called Kaleido Go. Run it against local hosts, say external key signing with some local keys that I've got going to be generated on my laptop, and use good old simple storage and just run 100 transactions per block, little background workloads here to sort of but mined against my local environment. And you can see those transactions flowing in. So those transactions are not flowing in because that application's connected to a node running in the cloud. That application's connected to a node running on my laptop. That node running on my laptop is joined through peer-to-peer networking and private transaction management end-to-end TLS with all of the other nodes in the network. So that's the end-to-end demo almost. I wanted to show you one extra piece, because One of the real challenges that stopped a lot of production networks from choosing to allow members to run their own nodes and infrastructure is the challenge of what about when somebody else wants to onboard? Does one member choosing to run a node and take on a big project to create production infrastructure inside of their organization, does that one member of the consortium end up stopping other members from automatically onboarding? And we decided, well, that's just not acceptable if it ever did. I mean, it really needs to be the case that there needs to be this flexibility and choice. So it should be the case that I can go, and we'll pop across to here and leave this running here. I can go back to Kaleido, and I can go back to the managed infrastructure, and I can add another node. And that same node will still be able to talk to all of the other nodes, both in the cloud and this new node that's running on my laptop. So node 4, let's choose somewhere else entirely. Let's choose Azure and the EU to be the location of this node. We'll go through and create it. And that node is starting just like the nodes that we talked about at the beginning of the call. But what's different now is that this node, as well as needing to be able to establish permissioned, and it's very important that it's still permissioned P2P connectivity with other nodes on the Kaleido backbone inside of that isolated, dedicated private network. It also needs to be able to establish peer-to-peer connectivity with a node that's running nowhere near Kaleido. It's running in a completely separate network on my laptop, the one I'm connected to Zoom on, right? So, and what it's actually been able to do is it's been able to reach back and broadcast that revision to what we call the network map. The network map has been updated to permission another node. You can take manual control over this, but this really is one of the powers of the system to allow that, that automated onboarding. And it's actually stood up a new peering connection, a proxy on my laptop for that remote node in the cloud. And that remote node is now started up, and that node is able to connect to the node that's running on my laptop. So if I pop back to my private environment here where we saw those 3 nodes connected before and do another admin.peers, you'll see that list has now changed to 4. And if I search for that node ID that got generated up in the cloud, we should see that that node ID is now one of the nodes that's connected, and it's connected using a local proxy, bidirectional proxy for that node. So that sort of completes the demo part. What we're now going to do before we sort of open up for questions, and I hope there will be lots, I'd like to take you through a little bit more detail on the architecture of how this works. Because it may seem a little bit like sort of magic and lots of components involved at this point, and sort of how can it be so simple but still fit with enterprise networking requirements. And one of the reasons why this has taken, I guess, a long incubation period for Kaleido, this technology has been being hardened for really quite a period of time with sponsored users, was to get this right. And this picture here shows the model we've taken for the architecture in order to support the enterprise, multi-tiered, very stringently controlled networks that are the home territory and known and loved and looked after by enterprise IT teams, sort of established environment of large enterprise organizations of the type that Kaleido is just used to dealing with. It's just sort of part of our DNA to think about the world in these terms. And what we do is we provide you with the ability to run a self-managed node in your own completely isolated network and be bi-directionally connected across all of those unadulterated, unchanged, open source protocols that node uses. So that's Dev P2P with UDP and TCP/IP connectivity. That's TLS with Tessera. That's Corda's underlying RPC connectivity, which is based on ActiveMQ's derivative at Apache Artemis. It's all of those connectivity layers unchanged. We're able to perform bi-directional connectivity. And the way that we're able to do that with nodes running on the Kaleido backbone or other nodes bridged to the Kaleido backbone across our multiple regions and clouds is by using the Kaleido bridge. And what the Kaleido bridge is, it's a two-parted runtime. One half runs fully under the management of Kaleido, which means that we have extremely strict controls of where this dedicated runtime, just for you in the environment, is able to connect to inside of the Kaleido network. And it's deployed into that dedicated virtual layer 2 network that we create for your business network. Each environment in Kaleido is a dedicated firewall isolated network, even though it runs cross cloud. That was, our second generation infrastructure. So layering this in is about providing a third generation to be able to bridge that externally. So this runtime runs fully managed by Kaleido, and then you run a copy of that runtime fully managed by you. And we used standard networking technology, packet encapsulation technology, and we chose very carefully, and it's aligned with the bridging technology that's commonly chosen by large cloud providers. We chose to use a WebSocket as the raw connectivity over which we tunnel the packet encapsulated rest of the networking. So completely standard technology, but customized to this use case. And one of the really nice things about choosing this is WebSockets over HTTPS is really proxy friendly. So you don't need to have a sophisticated environment to be able to connect from this local runtime that you're running up to Kaleido. And the connection direction of the network connection is from your local environment to Kaleido. So zero firewall ports need to be opened up anywhere in your organization to allow connectivity from outside in. It's only connectivity from inside out. And because you have this dedicated gateway runtime, that gateway runtime acts as a reverse proxy for your node to all of the other nodes in the environment. And it acts as a set of proxies and a router from your local network to all of these nodes in the cloud and other nodes that could be then bridged by their own runtimes. Now it turns out this is really helpful for enterprise networks because what it gives you is a runtime that is not the blockchain node, And you can run this runtime in a semi-trusted network, a yellow zone, a DMZ. This runtime does not need to run in the core network where the node is located. And the only thing that needs to be able to be connected from this runtime in your environment is the one IP address and port range of your self-managed node. That's it. So you can lock this in a network box. It also has inside of it the whitelist that we looked at, which is a software enforced box that you can lock it inside of. You can stick the whole thing inside of an environment like Kubernetes, or that has a virtualized network to itself, or get started in seconds on a laptop just using local networking. So this is designed to be as friendly as it possibly could be to the conversation that an enterprise will need to have with an IT organization and the networking team about, well, exactly how does this networking work? What ports are we going to have to open up in what networks? But most importantly of all, it allows this node to be put into the walled garden. It allows this node to go inside your environment. And one of the really big challenges in the few networks that have tried to sort of get all the way through to production with sort of connectivity across the internet is, well, how on earth do you manage that when you've got nodes that on one hand have core data inside of them, your private transaction enclave for Tesla, right? that data is really sensitive. So that means this needs to be an internal network, but this needs to be cross-connected with all of these other nodes that are running outside. How do I manage that? Well, the answer is that you need the split runtime approach. You need a runtime that can be semi-trusted and configured and isolated, that you can put in your DMZ or in Yellow Zone, and then you can put your node inside of that in a sanctum. And then the last point to mention here, and then hopefully you've all been preparing lots of questions. I'm sure there's been some in the chat that we can talk through. Nick, I'm sure will help you curate here. Is just to mention that we also have designed the technology with the reality that one of the things that organizations are trying to do, or business networks, much more importantly, a business network, a business ecosystem is trying to do with a technology like this, is show decentralization and that final piece, which is the infrastructure. For public networks, it's the first thing that anyone thinks about. Decentralization of the infrastructure. We need thousands of machines running across lots of countries with independent operation of the low-level machines. Well, that's not the first thing on the list for an enterprise network. For an enterprise network, it's about permissioning identities, keys, and data. All of those things are already solved, but you come to a point where if you're a participant in that network and you say, well, all the nodes are running Kaleido. Well, is that right for our network? Should we have some nodes which are completely independently operated, self-managed outside of Kaleido? Yes, of course you can do that. That's part of PrivateStack. Also, while we're using Kaleido as the backbone networking for this and the permissioning system, that's great. It allows us to onboard people in seconds. We can scale the network. This is fantastic. But some of those anchor tenants would like to cross-connect using their own network. They'd like to do those months of negotiation it takes to open up the firewall ports in both directions between the organizations. They'd like to do that. Fine, go ahead. That's great. We're really happy for you to create that independent connectivity between your nodes outside of Kaleido. But what we're doing with this infrastructure is we're providing you with self-service, immediate onboarding for those hundreds of thousands of participants in your network that want to have nodes in seconds, that want to use multi-tenant nodes. As a network operator, if we've got any network operators on the call, if you're that organization that's cross-funded by the participants or an independent entity, or you're just on loan from a number of those participants as a separate sort of operator of the network, you care about making sure the business doesn't slow down because some participants are choosing to self-manage. And this architectural approach is designed for that. Getting this right and not doing the industry the disservice of slowing down blockchain projects by sort of going back to the world that really was struggling a few years ago, where everyone was just trying to say, look, everyone stand up your own infrastructure and let's just try and cross-connect. Not going back to that, but allowing the good parts of that, allowing the advanced participants to run infrastructure themselves, allowing those advanced participants to cross-connect between each other, allowing bridging of ecosystems. Maybe you have an ecosystem that's managing Kaleido on this side. Maybe, and this is probably quite an advanced scenario, you actually got a separate permissioned environment that's running on the right-hand side with other providers. Allowing those scenarios, Kaleido with this third generation of our platform now can support all of those combinations without giving up on the core principles of flexibility and choice, speed of development of the platform, and allowing all of the tiers that you need for your technology stack, not just the 5 to 10% that's called blockchain technology, but enabling off-chain document exchange, enabling off-chain messaging, enabling all of these other layers that need to exist beyond the blockchain. They're going to use other protocols, other transports. So it's not just sort of a solution bespoke to one particular technology. It already supports all of those different networking interfaces, TCP, UDP, all the layers on top of those, like HTTP, but not restricted to HTTP, like RPC, but not restricted to RPC. All of those layers supported through the architecture. Okay, well, I've definitely talked enough at you for now. I'd love to open up for questions here. I don't know, Nick, have you been looking at them as they come through and you've got a suggestion for a few?
Yeah, I think some folks are still working up the courage to throw their questions in, but there's a couple that came in from Saul that we can address, asking about sort of running the local bridge on a Windows machine. So yeah, that's of course possible, Saul. We'll be adding a lot of additional documentation around the whole PrivateStack orchestration, a lot of those nuanced esoteric things Peter showed, but essentially, you just need to
Yeah.
grab the appropriate build for that piece of for your Windows machine, and then point it to that configuration file that Peter
Yeah.
downloaded. That's really
Yeah, let me just add a couple of bits to that next. So what we provide when you go to the downloads is we provide a binary distribution for the three most common platforms that we're working with. And that's Linux x86, that's Mac Darwin on x86 64 hardware, and that's Windows on x86 64 hardware. So we provide all of those pre-built. The Mac package is also signed, which is a hard requirement on Mac. So you get a signed download for Mac. One thing that Nick was alluding to there, for the Windows distribution, you'll find it's not a signed download at the moment, which is fine. You just have to accept that. But if a signed package is a blocker for you to be able to install it in your local environment, let us know, because that's something we're actively working on, providing a signed package for Windows as well.
cool. Thanks. Thanks for the additional detail. Another one from Saul. You definitely touched on this in a bunch of different capacities, Peter, but what is a good business case for this solution? I think I'll tee it up for you, but I think this is more, Saul, about the actual internal organizational requirements and how you want to actually, manage your own configurations and runtimes and actual key management as well. So I think it's more about internal security requirements and having the flexibility to allow the network to still grow and still expand with these different requirements as well.
Yeah, and the focus, just everything you've said there, Nick, I totally agree with. I was just going to add, it's about the right amounts, the right ways of decentralizing. It's critical if you're trying to transform an industry, right? That's what blockchain projects are about. They're about saying the industry's been working in silos. Now, rather than needing to do it that way or needing to trust one entity to be the sort of completely trusted source of infrastructure and data, and most importantly, sort of business trust, we're going to run this in a more decentralized way. And when enterprise projects are doing that, the first thing that's important to decentralize is that sort of ownership of the keys and the data. That's the first thing to decentralize. And that's where we've seen so much success in projects getting to production using cloud managed infrastructure, is being able to decentralize the really important bits, the business use case, and the ownership of the keys and data. But when you come to blockchain from the public blockchain space, where the first thing that got decentralized was kind of the infrastructure, because it's just a different problem trying to be solved. A lot of participants in these blockchain networks come like as a large bank or as a large supply chain company or as a large healthcare company, come with, this is core enterprise IT. Every piece of core enterprise IT we've ever done in our history has been done on-premise or on our own private infrastructure. Using managed for that, that's new, that's different. Is that the right thing for us to do? We at least need a roadmap that's going to get us to running our own infrastructure on-premise. Or they look at the network and they're saying, well, it's fantastic that we can decentralize the business and we can get to production in months, not in years. And it really is the difference between months and years that we've seen between those that have tried to roll their own completely, and let everybody do what they want in their own IT organizations and try to cross-connect. That's been years. Running fully on a managed provider, as we've seen, real production use cases get to production in months. So that's fantastic. But those same parties look and they say, well, is the infrastructure decentralized? Are we relying on one partner too much? Or when it comes to where the core data is located, actually some of the participants would like to be anchors that are going to demonstrate that they've got a complete copy of the blockchain. Maybe they're validating the blockchain, and they're actually putting in all of those months of effort to run their infrastructure in their own environment. And they're doing all of the hard work of the HA and the DR and all the like to keep the same uptime requirements that you get with a click of a button on infrastructure like Kaleido. But as a network now, it's not slowed down by having these participants, but those participants are getting what they expected. And maybe we have some on the call where it just naturally felt like going into enterprise blockchain, I'm going to be running my node in my network. That's just what I expected coming into this. This is delivering on that promise without coming with all of the baggage that comes by just saying, hey, look, everyone just running it in your own network, and let's try and work out how to cross-connect. Let's work out how to do rolling upgrades across 100 different participants. Let's work out flag days. Let's work out hard forks. Let's do that across 100 participants. Well, that's pretty tough. And even tougher is new participants joining our business network. The investment is a multi-month IT project. That participant probably doesn't want to do that. If the value from the network they're getting isn't in the value scale that's going to give them payback on that over time. So some participants are just going to say, no, give me a node as a service. I want it up in seconds. I don't want months of IT planning to build this node myself. Others are going to say, I don't even need a node. I just need a slice of a node. I just need access to the network. Hey, network operator, scale up your bank of multi-tenant nodes. Give me a Tesla signing key. Give me my own shard of a private enclave. Give me a set of signing capabilities backed by HSM. Do that fully managed. I don't want any responsibility for running infrastructure. I just want an identity in the network. So Kaleido's designed to provide all of those tiers of participation. Sorry for the long answer to the short question there, but I think it's a really important point of like, why do this? I think is a really, really good question, so I appreciate that.
Yeah, he's got another good one too, which may be worth you actually opening up the Q&A, Peter. But it's about sort of the, I guess, transaction and application architecture. Is there a front door through the UI on Kaleido to actually submit transactions if you're only running a local PrivateStack Kaleido node, or does your application need to be run sort of alongside, and those transactions need to be submitted alongside your PrivateStack node?
That's a great question. So I guess the very short answer is no. There's no way for Kaleido to, at the moment, to sort of provide a cloud-hosted send transaction endpoint on this side for a node that's running on-premise. We haven't yet had that as a requirement. But what we are doing is filling out PrivateStack with those capabilities, like the REST API gateway, like the off-chain document and message transfer capability, so that this stack isn't limited just to the node. So you have that fuller stack. Right now it is the node when you just go and start, but if you've got a business requirement around some of the other capabilities in the stack, like REST API gateway and the like, those capabilities were all packaged in a way that it's very simple for us to add them into PrivateStack. So we'll be doing that as we go forwards. Now, what I would just like to mention related to the question, Sol, and I know this is a bit of a divergence, but I'll only spend a minute on it, but it's a really important concept, is Kaleido is built so that if the real requirement here is private transactions and data, but a really simple endpoint to submit them, I'd like to mention two features of Kaleido that work really nicely with hosted nodes. One is our cloud Hsm Sign Up. Now, what this does is it says I can still have my node managed for me up inside of Kaleido, but the really sensitive bit, those keys, never ever need to be in Kaleido, because I can have them in my own FIPS compliance Cloud HSM provided by AWS or Azure Key Vault, or I can create a double secured trusted key path down to my own key management software infrastructure, which is running on HashiCorp Vault. And then you mentioned open it up to the internet. Well, there's a lot behind opening something up to the internet. And we also provide another feature which I'd like to mention, for that, which I know we've done a Tech Tuesday on previously. And that's called the Blockchain Application Firewall. And what this is, and it compromises the word firewall in exactly the same way that web application firewalls did. So web application firewalls did it first, but it's a reverse proxy designed for blockchain. It sits in that sort of public cloud environment and can expose a connection to the internet, or you can secure it over private link just to be internal. But you can provide a connection over the internet, and you get modern application security with JWTs, OAuth 2, OpenID Connect. And then you get really detailed rule-based role mapping down to very explicit control of what they can and can't do. So you can authorize them to one individual key based on a claim that goes into the output of logging in. You can, but you don't have, or you can have wallets with the keys externally provided in the cloud. This technology is part of the stack that I said could go into that PrivateStack environment. If you needed it for a project, it could be run alongside the node on premise. If you're interested in that, that's definitely a possibility. Also, you might find that actually cloud-hosted nodes fit your needs because you're able to provide this entry point and combine it with those HSM-backed signing keys to mean that the keys themselves aren't ever up in the cloud. So I hope that answered the question there. Any follow-ons to that, or a follow-on question there, Nick?
There's a few questions on billing, which we can take the commercials offline. Fawaz and Saul, I believe, were the two ones that asked that. A question from Ian, which I believe you just addressed, unless I misheard you, asking about the sort of the REST API gateway, the Kaleido Easy button alongside the PrivateStack node, and I believe you said that we're going to continue packaging enhancements and additional features to run locally as well.
Yeah, I'd be really happy to take that one offline for an email exchange if you wanted a little bit more detail on that, or maybe you could share a little bit about your project and project timelines. But let's take that one offline in terms of the detail, but the general answer is coming soon.
Great, thanks, Peter. One in the chat as well. I guess I'll skip the preamble. How do you prevent that a PrivateStack node doesn't cheat? In other words, how do you provide verifiable computation in PrivateStack?
Through the consensus algorithm, I guess is the short answer. You designing your business network, or as a group designing the business network, because that's the challenge here. And opening the door to allowing some of those members to run on-premise infrastructure does change the threat model for managing your environment, and it does mean you need to think about who are the validators in the network. And I think it's a great question, but it's not quite so much a technology question as it is a business network design question. And maybe you're coming from the perspective of, I'm the network operator, am I opening Pandora's box here? And the answer is, we've tried really hard to make this safer than any other approach to allowing infrastructure decentralization of where nodes are running. And we've left in place all of the security controls of IBFT and the core open source as part of doing this. But there is a change as part of doing this. And it's one of the reasons why there's been so much traction in permission blockchain with fully managed infrastructure. It's the reason why that's been the way to get projects to deliver business value quickly so far. But we really feel like this sort of third generation of technology in Kaleido represents kind of a third generation of maturity in these networks, where looking to provide infrastructure decentralization is a core. It's popping to the top of the list for production networks. It's coming to the point of being a sort of an unanswered question that networks want to be able to answer for their members. But it needs to be done with eyes open, and it needs the whole community, whether that's through a network operator, or it's through collaboration between the participants to agree to the right way to do it. So sorry, there's not a simple answer to that one. That's why I think we could spend an hour just on that question. So it would be lovely to kind of talk about that one offline as well, maybe through a detailed exchange. But the short answer is blockchain. Blockchain is the way that you prevent execution of the data. We're choosing the right consensus algorithm and distributing the validators across PrivateStack nodes, across different clouds, across different owners. It's the most important thing. Different owners, different legal entities. That's the way that you protect the computer.
Awesome. Well, thanks for all the talking and a really enlightening demonstration there, Peter. This is super cool stuff, even to myself, and I've seen it a handful of times now. So thanks everyone else for attending. I've shared my email inside of the chat, so please don't hesitate to reach out for any follow-up technicals or commercials. This was recorded. It probably makes sense if you want to have another look at it. So we'll be emailing this out within the next 24 hours. Showed you guys the YouTube page at the beginning, but just search Kaleido Blockchain on YouTube. You can find all of the curated videos from past sessions. And then just please keep a lookout for new topics on upcoming Tech Tuesdays. I'm going to continue trying to pull in a few of our engineers for increased insights into the areas that they have the real expertise. So thanks again, everyone, for attending. Hope you're staying safe. Hope you're staying healthy. And do not hesitate to reach out with any questions. And another big thank you to Peter for taking an hour out of his day to do this.
Thanks, everyone.
All right. See you next Tuesday. Bye.